Right, hi guys. This is the first time I've ever done this before, recording on a PowerPoint. But hopefully, when you've seen this, it will give you a good idea of the beginnings of understanding calculus. So this is my introduction to calculus. Now I want you to, first of all, imagine a motorcycle. And imagine that it accelerates from rest into about 32 meters per second in 12 seconds. It stays at this velocity for 28 seconds, and then it has to stop quickly in 8 seconds. Now, you might have done questions a little bit like this at school. And probably what you would have done with that information at school is to draw a graph. And you probably would have got something like this. This is a velocity time graph. Now, the velocity time graph, what it does, it shows us the speed as time increases. And in the first 12 seconds, you can see its speed's increasing quite quickly, and it gets to 32 meters per second. Then the graph is completely flat because it stays at that velocity for the next 28 seconds. And then the line goes down quite steeply because it stops very quickly in 8 seconds. Now, why do we do a graph like that? What's the point of that? Well, there's two things we can do particularly with this graph. Obviously, apart from just read off the velocity, we can actually calculate some other things from this graph. The first thing we can calculate is the acceleration. The acceleration is actually the gradient or the slope of the line. So the first bit has a fairly steep positive slope. Then we have a flat zero slope. And then we have a negative, quite steep slope. That tells you what's happening to the acceleration. And we can calculate the slope of that. The second thing you can calculate is the distance travelled by this motorcycle. And that is calculating the area under the graph. So you'd have to calculate the area of the triangle, the first triangle. You'd have to calculate the area of the rectangle. And you'd have to calculate the area of the third triangle. So first of all, let's look at the acceleration. So here's the same graph again. Remember, the acceleration on this graph is the slope of the graph. Now, to work out the gradient, we did this back in the first assignment. To work out the gradient, you basically have to use the formula. The gradient is the change in the y values divided by the change in the x values. So in this case, the change in the y values is 32 take away 0, and the change in the x value is 12 take away 0. So we get an acceleration, or a gradient, of 2.67. Okay, well, here's the same graph again, but this time we're going to calculate the distance travelled by the motorcycle. Now, on a velocity time graph, the slope or the gradient of the graph, that gives you the acceleration, but the area under the graph gives you the distance travelled. So to work out the area under this graph, it's a trapezium, and we've actually got to calculate the area of A, a triangle A, area of B, a rectangle, and area C, which is another triangle. And the area of a triangle is just half times the base distance times the height. So we end up getting the total area is a half times 12 times 32. That's the first triangle. Then the area of B is its length, which is 40 minus 12, times its height, which is 32. And the area C is half base times height, so it's half times 48 minus 40, and then times by 32. And if you do all that, you get an area of 1,216, and that must be the distance travelled, so that's 1,216 meters. A velocity time graph is really useful, but it's only just one type of graph. And to be honest, most graphs, like that graph, have things that their slope means and things that the area means. So they mean something different to what the main graph is about. So for example, in a distance time graph, the slope of the graph is the velocity. Or in a voltage current graph, the slope of the graph is the resistance. Or in a capacitance versus time graph, the area is the charge stored in the capacitor. And in an acceleration versus time graph, the area under the graph gives you the velocity. So quite often, the area and the slope mean something else. Right, so here's another example. This is a force versus distance graph for a mass hanging on a spring. Now you may have done something like this before when you're at school in science. And what you did was you put maybe different masses or different weights on the spring, and then you worked out how much the spring stretched. Okay, now there's a graph. It's a straight line graph actually. And the question I want you to think about is, what do you think the gradient of that graph represents? And also I want you to think about, what do you think the area under the graph represents? So the line actually shows us the force and the extension, but the gradient in this situation, actually, if it was steeper, it would mean that when we put a force on the spring, it wouldn't stretch very much. Or if it was the gradient of the graph was a bit flatter, it meant that if we put a force on the spring, it would stretch a lot. So the actual gradient of this graph represents the stiffness of the spring, how stretchy it is. If it's not very stretchy, it will have a high number, it will be a steep slope, and if it is stretchy, it will be a very flat slope. Okay, the other thing is, what does the area under the graph represent? Well, in this case, the area under the graph is not that obvious, to be honest, but the area under the graph is actually the energy stored inside that spring. So when you stretch it, the more you stretch it, the more the area increases and the more energy is stored in the spring. So I'm hoping you're getting the hang of the fact that when you see a graph, you can see the main detail of the graph, but you can also work out other things from the graph. The slope is important, and the area under the graph is important, and often they are something very different. Now that's all very well with nice straight line graphs, and that's the sort of graphs you probably did at school. But in reality, most things don't give you straight lines. Most things are much more complicated than that. Bikes don't accelerate with a constant acceleration in a straight line. They actually go up and down. It's much more complicated than that. Basically, we have curved lines. Now, working out the slope and the area under those graphs is obviously a lot more complicated. But this is really what calculus is all about.